Welcome to the math record. Today I'll be covering the first convergence test, the integral test. So basically, if we're given a summation from 1 to infinity of f of x, this summation by the integral test tells us that if our integral from 1 to infinity of f of x d of x, if this integral converges, then so does our summation. So it's just that simple. Let's try some examples to understand this. So if we take the summation from x equals 1 to infinity of 1 divided by x plus 1 to the power 2, if we want to check if it converges, take the integral from 1 to infinity of 1 divided by x plus 1 to the power 2. This is the same thing as saying x plus 1 to the power negative 2 dx. Taking the integral of that is x plus 1 at 1, so that's negative 1. When we take the derivative, this is negative 1 x plus 1. Negative 1 minus 1 is negative 2. And the derivative of x plus 1 is just 1, so it does nothing. So we want this to be positive, not negative, so we multiply this by another negative. So this would just simplify as negative 1 over x plus 1, and that we evaluate from infinity to 1. Now we plug in infinity here, that's negative 1 over infinity plus 1 is infinity, minus plug in 1, so negative 1 over 1 plus 1 is 2, so minus negative 1 over 2. So if you think about it, negative 1 over infinity, if you keep getting bigger numbers, this is going to approach 0. So the limit of this is going to become 0. So 0 minus negative 1/2 is 1/2. So since this converges to a number 1/2, then so does our limit. Okay, that was pretty simple. Let's try another example. Let's say we want to find if the summation from x equals 1 to infinity of x divided by x squared plus 1 if this converges. Well, using our integral test from 1 to infinity, and x divided by x squared plus 1 dx. And we could use a u sub, so u equals x squared plus 1, derivative of u, and the derivative of x squared is 2x dx. Move the 2 to the other side. So x and dx is right here, so we can substitute that with 1/2 du, and we can substitute that here. So that is the integral of 1 over u and 1/2 du. 1/2 is a scalar, so we can move it outside the integral, du. Integrating a reciprocal, as we've done before, is always just going to be the natural log. Now substitute our u back in, which was x squared plus 1, and absolute value, and we evaluate it from 1 to infinity. Now 1/2, if we plug in infinity, infinity squared plus 1 is infinity, and natural log of infinity. And if we plug in 1, 1 squared is 1 plus 1 is 2, so minus 1/2 natural log of 2. Well, this is going to diverge because natural log of infinity is infinity. So 1/2 times infinity is infinity, and infinity minus a number is always going to be infinity. So overall, since it's infinity, we know that our equation is going to diverge. Our integral is going to diverge, so does our summation. Well, that's basically everything. Thanks for watching, and in the next video, I'll cover the second convergence test, the comparison test.